we'll be drunk and all of the thumbs went up in the air. Singing in the wind, listen to the thunder rolling over and over. We down, we're getting on fire, we're raising up higher. The bottle is up, we're over the...
Yeah, welcome back for this particular STEM communication Junior Maths Olympiad lecture 002, okay, on permutation, combination, and probability component of the syllabus. So we're looking at part 2. I think we are probably going to do another one on this because there are still some stuff I need to expose you to. So we have 4 questions to address on this particular section. Okay, let's start. Meanwhile, I've already given some kind of interpretation on permutation and combination in 001 of this particular series, so I need to go back to that so you can have a flashback, a recap on that, so that you're able to pick the appropriate illustration and explanation. Now, question number 1. Yomi was asked to label 4 seats with letters A, B, C, D. What is the probability that he labeled them in alphabetical order? Number 1, A, B, C, D. So those are 4 letters. 4 letters. No repetition. 4 letters. No repetitions. Permutation. That is 4 permutation 4. If you interpret this, it's something as just say 4 factorial. So there are 4 ways this can be arranged. 4 factorials means 4 times 3 times 2 times 1. That will give you 24 ways. Now, out of these 24 ways, they said, what is the probability that he labeled them in alphabetical order? You can only have one alphabetical order out of these 24 orders. Okay? Out of these 24 ways, you can only have one way that is alphabetical. So, probability is expected event, which is one order, over total sample space, which is 24. So the answer is this. Simple. 1 over 24. Hope you get that. Alright. Now, question number 2. The probabilities that a husband and wife will be alive in 20 years' time are M and N, respectively. So we have hubby, husband. We have wife. Alive. That they will be alive. The opposite of being alive is dead. That they will be alive, husband is M, wife is N. Don't forget that total probability must not be more than 1. So that if husband to be alive is M, to be dead will be 1 minus N. If wife to be alive is N, to be dead is 1 minus N. Is that clear? Okay. Now, find that only one of them will be alive at that time, in 20 years' time. Only one of them. So look at probability. Only one of them will be alive. This is interpretation. Let's say the husband is alive. Then the wife will not be alive. 1 minus N. Or let's say the wife is alive. Then the husband with the second person will not be alive. 1 minus N. Those are the 2 things. All must come in. All in probability means plus. That's interpretation. So you now open the bracket. This is M into 1 minus N plus N into 1 minus N. Open the bracket. This is M minus Mn plus N times 1 plus N minus Mn. Now this is, we have M, this is M plus N. These 2 goes together, minus Mn minus Mn. That is minus 1 Mn minus 1 Mn. That's minus 2 Mn. That is the answer. Do you have the option? Yes. So C is the correct answer to that. Okay. Now, let's go to question 3. Please be attentive in this question 3. Very important that you are attentive. Okay? Very, very important that you are attentive. Because it's a bit technical. Okay? Now, we are going to use this question to answer question 3 and 4. Find the number of ways in which the letters of the word fellows can be arranged. Fellows, we have this letter, fellows. How many? 1, 2, 3, 4, 5, 6, 7. So there are 7 altogether. 7 letters make up the word fellows. Now, find the number of ways in which the letters of the word fellows can be arranged if the two L's must be separated. So let's remove the 2L. Remove the 2 L's. We are left with 5 letters. So that means we have OWS. We have 5 letters left. So it means these 5 letters, you have to arrange this one first. What are the possible ways they can be arranged? That is 5 factorials. Now, we have the 2 L's. We can be placed either here, this place, or this place. How many places is that? 1, 2, 3, 4, 5, 6. So the 2 L can be in any of these 6 places. So you write that 6 first. Did you understand that? Okay, let's start with. Let's arrange after removing the 2 L, let's arrange the possible ways the remaining letter can be arranged. That is 5 factorial. Okay, let me start with that one. The possible ways it can be arranged. This WFE, it can be EFO, it can be OK. That is 5 factorials. Now, the first L out of the 2 L, have placements, positional placement of 6. 1, 2, 3, 4, 5, 6. So that is 6 times the second L. After we have fixed one, have 5 positional opportunities to be placed times 5. Now, if you look at this question, the 2 L are alike. So we wouldn't know which one is placed first or which one is placed second. And even the L's are colored. Maybe one is red, one is green. This is the answer. But in this case, the 2 L are the same. So you have to divide by 2. So this is 5 factorial. 5 factorial means 5 times 4 times 3 times 2 times 1. Then times 6 times 5 divided by 2. That is the result. So do that and see whether you get one of the options there. Now let's go to question number 4. Question number 4. Now, find the number of ways in which the letters of the word fellows can be arranged if the 2 L's must always be together. Fellow, look at it. Now, if the 2 L are to be together, that means they are the same. That's the meaning. So how many do we have to permute now? We have 1, 2, 3, 4, 5, 6. We have 6 factorials. 6 ways this can be arranged. There are 6 ways. Okay? Are you following? There are 6 ways this can be arranged. If they must be together. So there are 6 ways. Sorry, I made a mistake there. So we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There are 6 of them. So let's remove those L that are the same. Let's remove those L that are the same. Yeah. If you remove them, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5 factorials to be arranged. Okay? 5 factorials. 5 to the letters to be arranged. We have removed this. So now, by the time you have this, the 2 L must be together. Can either be here, or here. 1, 2, 3, 4, 5, 6. 6 possible placements for them. Do you understand? So the permutation is of the remaining letters is 5 factorial. Then the 2 L, since they must be together, I only take their placement is just 6. Yes, that's it. So this will be 5 times 4 times 3 times 2 times 6. 5 times 4 is 20. 2 times 3 is 6. 20, that's 120 times 6. I think that is 720. So that one is this. Thank you. See me in the third video on this topic where we look at other possible questions. Thank you very much.
Down the river we drunk and all of our thumbs went up in the air.